All right. Before we jump into chemistry, yesterday with the 10-minute homeroom, teachers were supposed to show a short, like less than 2-minute video. I had no internet, so I couldn't do it. So they've asked us just to kind of show it to everybody today. So if you've already seen it, I apologize, but it's super short. It's just reviewing some of the policies that administration wants you guys to remember. That's all. So let's just take less than 2 minutes here. It's kind of jumpy, the version that I downloaded, but you'll get the point.
The Plant High administration would like to remind you about a few school policies as we head towards the second semester. Dress code. It is important that all PHS students adhere to the dress code outlined in the student handbook. Remember that hats and hoodies need to be removed before entering the building, and shirts and shorts should be the appropriate length. Lunches. It is important for students to eat lunch only in the approved areas. Cafeteria, main patio, and the media center are open during all lunches. Please remember to clean up after yourself when you are finished eating. Parking lot. Please note that the parking lot is off limits during the school day. If you have an emergency, contact the front office. Also, parents need to call the student affairs office before students leave campus. If you are not in class, you need a pass. Restrooms. Lastly, please be considerate of others in the restrooms. Remember that there is only one person per stall allowed. And please remember to clean up after yourself. We hope these reminders will help all of us to stay in compliance as we enjoy another great year at Plant High School.
All right. Exciting stuff, just reviewing there. Okay, so now let's jump back to chemistry. So we're going to go over the intermolecular force practice from yesterday, and then you're going to work on another paper. And guys, that's it for the unit. So your binder quiz tomorrow, it's these two papers, 78 and 79 with the resources. It's 6 questions. That's it. So you want to make sure you're good to go for that for your binder quiz, resources, and then 78, 79. All right, so with that, let's take a look at 78, the intermolecular forces practice. So we got number 1 at the top there, but a couple of things that I noticed here when I was looking over these. First of all, I did add some notes under my molecular polarity. If it was polar, I put notes about when I checked for hydrogen bonding. So like the first one had hydrogen, but it didn't have one of the fun guys. So that's why it wasn't hydrogen bonding. But the second one had hydrogen bonded to nitrogen, so we were good. You didn't have to have those. I've just added them to my key. Dot structures. Some of you guys need to go back and review your dot structures. If you had what I felt like were a lot of issues, I made a comment. Some of you only had 1 or 2 issues. So make sure for your exam, you guys have to know how to do dot structures, even if you could get the right answers on this worksheet. The other thing that I saw, some students did subtractions of electronegativities for the molecular polarity. You do that for bond polarity, not molecular polarity. In molecular polarity, it's all about the shape. That's it. You just look at the shape for molecular polarity because it could have polar bonds or nonpolar bonds. It doesn't matter what the bonds are. It's about the shape that's going to determine the molecular polarity. So with that, there's going to be one of these on here that you guys were like, might have said, oh, it's ionic. First of all, when we're talking about intermolecular forces, there is no ionic anything. These are intermolecular forces. Everything on here was a nonmetal. There was not a metal in sight. Meaning even if you subtracted the electronegativities, every single thing on here was covalently bonded and exists as a molecule, except for the last one that was just one atom, right? So really your only decision was, is this thing polar or nonpolar? And so that became an issue for some of the only 2 atoms. So we had 2 diatomics, the chlorine and the nitrogen. And in that case, their electronegativities would have been the same. So it would have been a nonpolar bond, and it would have be a nonpolar molecule. But we'll get down to the other one that was a little weird, and I'll talk about that when I get there. So with that, let me close my mouth for a little bit. You guys make sure you got correct answers. 1 through letter E. All right, did we catch for letter E? That was boron. That only needed 6. So you did not, nor should you ever make a double bond with hydrogen, because hydrogen only needs 2. All right, questions right now, A through E. Okay, so then scrolling down for the last set. So we had that diatomic nitrogen. So if it's the same atoms, that's always going to be a nonpolar bond, which would be a nonpolar molecule. But it was the HF. This is the one that gave students a fit, because if you do the subtraction, it says that it's ionic, but guys, it's not. It's 2 nonmetals. That's why that whole subtracting thing is not perfect. It's not 100%. It's just a guideline. So this is not ionic. It is a molecule. And then how are you supposed to know it was polar or nonpolar? You were not supposed to do any subtractions for anything. What I was hoping is that you would recognize that they are not near each other on the periodic table. And if they're not close to each other on the periodic table, that means they do not have similar electronegativities. So without knowing a number, I just needed to know, hey, their electronegativities were different, that's polar. I'm not going to give you oxygen and fluorine that are right next to each other, because then I'd have to do the math to check. But if they're far apart, hydrogen pretty much with anything over there is going to be polar. Hydrogen with chlorine, hydrogen with fluorine, hydrogen with nitrogen, those are going to be polar because they're not close to each other. So that's what I was really hoping for on letter H, that you would just recognize that since they're not close, their electronegativities are different. A, that makes it a polar bond. B, that makes it a polar molecule. But even if you missed that, it had hydrogen bonding. So it had hydrogen bonded to a fungi. So you probably still could have gotten here even if you messed up the polar, nonpolar part. All right, so with that, let's check out the rest of these. So last call questions on any of this. Yes? So if you recall yesterday in our notes, I had you add that it was nonpolar molecules or non-metal atoms. They have dispersion forces because I would never say that an atom has a charged side. Atoms are neutral. But the electrons can shift to one side temporarily, which is why they can have dispersion forces. All right, other questions? Okay, so what I want to pause real quick and show you guys, I grabbed some animations showing the different types of intermolecular forces so that you can visualize some of the differences between them. So here we start off with dispersion forces. We have 2 diatomic molecules. Pausing it here, the little blobby things, that's supposed to be the electron cloud. So notice they're pretty equal on both sides. That's status quo for a nonpolar molecule. But what's going to happen is sometimes based on the random movement when they get close to each other, you're going to see the shift. So now see how the blobbies have shifted? Now we have this giant blob over here. That means the electrons have shifted more to that right side. And the same thing's happened here. That is what has created these partial charges temporarily. And so that's when the attraction develops. That is the dispersion attraction. But based on the electron movement, they're going to go away on their own, right? And they go back and separate. So now we're looking at the dipole-dipole. The difference here, yeah, they're kind of going apart and separating, but the charges don't go away. The charges are always there. We always have the red side partial positive, the blue side partial negative. And so you can always have attractions forming. So why are they going away, breaking and forming right here? That would imply there's some energy around. It could also be a liquid. A liquid, they stick together pretty well, but they sometimes will move a little bit, hence they're flowing, right? So that's probably a better explanation. This is a liquid, not a solid. So let's just finish this one, showing the breaking and forming, but it is every time you see a positive get next to a negative, that's the attraction of the dipole-dipole force. And then now the hydrogen bonding, very similar to the dipole-dipole, right? Here we have our always partial negative oxygen and water. Here we have our always partial positive hydrogens, and so they always line up, opposite charges attract. But remember, these are extra special because there are more extreme partial charges. It's a stronger version of a dipole-dipole because of the greater partial charge on the hydrogen due to the bonding with one of the fun guys. Okay. So hopefully that helps with some of the visualization of the different intermolecular forces. Questions? All right, then that leads us to our task for today. This is number 79, your lesson 11.2 textbook worksheet. It says that at the top. This is due tomorrow, which is Wednesday, 8:25 a.m. as a single PDF on Canvas. And you get the rest of the period to work on it using your textbook. This does start on page 403 in the textbook. And it is just from section 2, from lesson 2, which, guys, is only about 4 pages. That's it. It's not a really long section, so I do encourage you to read the section. I think there's something to be said for reading it once and then going back and trying to do the worksheet. But it's got vocab and what have you, and stuff goes along with the textbook with the get it questions, right? So that's kind of the review information. They do have a couple of practice questions at the end, starting with number 14. And then that last little study guide, that's kind of like the final review for that section on intermolecular forces. So use the rest of the period to work on that. And should you finish, you are allowed to scan and upload from class. But that's it, guys. This is your test. These 2 pages, what we did yesterday, what you're doing today with the textbook. The textbook hopefully will reinforce a lot of the stuff we talked about and add maybe a couple of new details that we didn't mention yesterday. But mostly we should have talked about what's in there. Questions? Yes? Anything else? Okie dokie, then get to it.